Hello everyone, this is Birdy. Welcome to a new lesson in Houdini. Today we'll continue our journey in the advanced river in Houdini. Today we will continue complete the setup of the river in the .NET network. Also we will explain some concept about the boundary layer and how it works. So let's get started. Let's try two things because the velocity here in the particles and here I think I deleted. Okay. Let's try two things. First try. Let's make a volume. There are more than a way to do it. This is a vector. Let's call it val. Initial value. Let's put it 1 in the z direction. Here let's choose by size. Let's type match size. This is the first way. Now if we type I, we have the velocity, but we need to increase the velocity. Let's type 0.1. Let's see, 10 by 10 by 10. Okay, let's increase it more, maybe 0.01. Of course this is reducing, but when you reduce it, it increases the velocity volume, the voxel. So let's see the velocity. Let's add volume trail just to demonstration to see it. Let's choose volume slice. Let's add it. Let's see it. This is the velocity that we have. Looks a little weird. Okay. This is the velocity that we have. It read only one rectangle or one cube. I think it should read the two cube that we have. Let's try something else. Let's see. Same result. Okay. This is the first way. Now we have velocity, volume in a specific direction, and also we can add volume velocity to add curl noise to the velocity. Add curl. Now as we can see, we have a curl velocity now, right? It's curl, but it's as well in a direction, specific direction, but it's curly, right? So let's add it there. Let's play to see. I don't know why this space, where it came from. Yeah, I think it's working now, as we can see from the color of the velocity. The light blue is the fast particle that has more speed, fast speed. Let's see the surface to see its surface, the shape that we have. As we can see now, the water keep coming, its flow. I don't like the shape too much, but we can do some modification. Let's change it to particle field. Of course, we cannot change it to a particle field, because if we change it to a particle field, it will not going to emit any fluid. So I will correct it later. Now let's add flip source to the boolean. As we can see now, there is a problem. I have to change it back again to surface, emit from surface, not from particle. As we can see, input, yeah, input type particle fields. That's the problem. Of course, this is a translation, so I cannot change it now, but I will change it in this video later. Okay, but that was the problem. Yeah, so now I'm trying to fix the problem. Yeah, the problem is the particle field. It should be surface particle, or read from surface, input type surface, geometry surface. Yeah, we have this kind of this shape. I think it's from the velocity itself. It's from the velocity itself. The problem was because it was from VDB. He cannot pull in. We cannot pull in a VDB. So we can use this one, not a VDB. Let's put another. So let's choose in the boss out. Yeah, so trade it back. To have more details, let's put 0.05 to add more voxel. The attribute noise, move it a little. So let's delete the noise and add mountain. Mountain is better. Mountain is a good boy. Yeah, something like this. Time, let's add dollar sign T capital to do some animate. Yeah, it's not playing. That was the problem. Now I'm trying to figure out why it's not move in every frame or play. Yeah, it's playing now. By 5 to make it a little slower. Maybe 10 by 10. Yeah, started to get slower. Okay. So this can mimic the effect of the water. Velocity volume in this direction. Let's add null. Out boundary velocity. Capital, of course. Let's select this one. And drag and drop the out boundary velocity in the velocity volume. So this is the first way. Let's try another method. This is the first method. Let's try another method. Okay, so there is two methods. This is the first method. Let's try another method. I think this was by volume. We don't need the trail only for demonstration purpose. To just see the velocity only. Let's put it in a folder and type simple one, just for the sake of organization. Let's make the sample too. Maybe it will be better than this. Let's add point from volume. We're not going to use the particle we have, but we will use the volume. We can connect particle separation from the flip object. Let's take copy parameter, then paste it here. Parameter reference. Yeah, relative reference. So we have the points now. This point we need to add the velocity. Then we need to convert it to a volume or a VDB, right? And we can add curve noise to it, right? Direction, it has a direction. but also it's curly direction. So let's add point velocity. It added velocity v attribute. Let's keep it add keep incoming. This is important. Second, let's check the curve noise, and also add velocity in the direction. Put it to the direction z1, same direction of the river. We can connect this velocity here to this velocity here. Let's copy this velocity and paste it here. Paste relative reference. This step is not important because it will not going to read the velocity here. So this step is not necessary. So maybe you can delete it. Even we don't have to check it. It reads only the volume. It doesn't read the particles from the point from volume, right? That's why we made a new particle velocity from the point velocity node to add a velocity to the point that we created. So maybe we can add this to see it. Maybe you can increase and decrease the swirl size. Of course, this is for demonstration only. Okay, we don't want to see it. Now next step. We need to convert the velocity to volume or a VDB. Right? Here we have the velocity as an attribute in the point, but we need to read it as a volume surface. So let's add attribute rasterize volume rasterize attribute, only convert the V. So now it will convert the velocity to a volume. Also there is something we can do to make the shape of the velocity same as the shape of the volume there. We go there and add scale attribute. Don't forget to add scale attribute in the point from volume. So we'll have the same size of velocity now, right? Maybe we can increase the points a little bit. Maybe we can increase the voxel 0.05. Of course, when we decrease the number, this means we will add more voxel size. We will reduce the voxel size, so that we will have more voxel. So now let's add null. Also, if you want to see it, we can add trail volume as usual. Connect both. Then add volume slice. And then add it here in the left. Let's like this. Let's type V to see the velocity. And there is no velocity. Where is the velocity? Yeah, I'm trying to search to know why it's not. The V is a vector, but only one vector. This is a different, because in this velocity, I think this is a VDB velocity. That's why it's only type it in only one line. So maybe this is from the scene view. Let's close the scene view. Let's open another scene from new. No, 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 no. View, scene view. Yeah. Take time to caching. Let's select the volume trail. Still nothing. It's not important. Maybe I will figure it later. I'm not sure. I have here. I think we should name it vel, not v. No, no, no. This is because this is a VDB. It's one line, not three line. Not vel.x, vel.y, vel.z. Because the other is a volume, but this one is VDB. Volume rasterize attribute. So I'm trying to do something not important. Maybe just to see the velocity. For me, okay. Let's go to the file source. Let's type velocity copy parameter. Here in the channel, place relative refresh. As we can see, I add a vel. Yeah, that's a problem. Yeah, this is a volume. This is volume, vector volume in 3 lines. The volume trailer, I'm not sure where is the problem. But anyway, this was only for the demonstration. So now we have the null. Out boundary layer. Let's name it out boundary layer. Let's drag and drop it in the flip solver and the velocity volume. So that was the second. That was the second method. Of course, it's better to see it as a particle, not as a surface. Sometimes it gives us an art effect like this line. There must be this shape. There must be a distortion between the surface volume and the other volume. We don't have to show this from the beginning. We can only show the river like this. Let's go to guide particle to show the particle. Maybe we can add more particle by decreasing the number of particle separation. Yeah, it's not moving. Yeah, okay. Let's check it to add velocity. Now it should flow better. I think it's flow better now. Started to mix and blend together. Let's increase it to 2. So we have a velocity in a specific direction, z, and we added a curl noise as well. Okay. So the particle is not straight, just straight. It's straight but with curly, right? Like hair, curly hair, for example. Looks better. When we increase the box size, the problem solved. I think the problem was in the box size. Particle keep flowing. There's something I want to correct. When we give it a boundary layer, the whole shape like this, it wouldn't collect all of it. It will receive only the surface volume, the lower banding and upper banding only. It will calculate. It will receive these parts only. The particle will receive in these parts only. You must have a shape for a lower banding and upper banding. So it cut 1 meter from each side of or each axis of z, right? And it must be positive, not negative. Here it will calculate the particle inside this volume only. But even if we give it a shape, the whole shape of the river, as we can see now, it will still work, but it will take more time in calculation. Yeah, same thing, but it will be a little slow. So when we only do the edge as a boundary layer, to recede the particle and give it a direction, it will be more faster. But I think this shape looks better. Looks more realistic. If we give it the whole shape, the whole river as a boundary layer. Okay, let's choose this. Now the boundary layer, we are finished now. Let's put it Shift L to layout it and select it and put it in a folder like this. Name it sample 2 maybe. So this is the best way to create velocity volume for the boundary layer. Okay. It will be a volume or a VDB. This is volume and this is VDB. Yeah. Now I figure out it's a VDB and this is volume. Yeah. Volume give us three lines. The VDB give us only, the vector give us only one volume. Okay. X, Y, Z. Treat it as a vector, but it's written in one line. Yeah, volume rasterize attribute converted to a VDB volume. It doesn't write as a VDB, but it converted to a VDB. Okay, both of them are volume, but the VDB is different than volume. Okay. There's something I want to change here in the dub network. First, I don't want all this panel. I'll simply close this, close all this. Yeah. So, make it as a network. Shift L to layout it. Then you can move it just for the sake of organization. And this is too simple. I repeat things actually. Sorry about that, to repeat things many times. In the future tutorial, I will not going to repeat things like this. As I said, this is a recording and I just record the voice again to translate from Arabic to English so people can understand. So now, as I said, there is something I want to change in the dub network. I want to add vorticity. Okay, what is a river? Also, velocity transform, change it to swirl canal. Splashy is for ocean, like waves and this stuff. But swirly is for river. Okay. something we can add it. Let's make add more particle by decreasing the number, reduce it to 0.05. Substep, let's make it 2. It will improve the resolution, but let's make it 1, but you can make it 2 if you want. The advantage of using the fluid from object, it create the fluid that was the end of this lesson. I hope you enjoy it. If you have any question, please type it in the comment section below, and please subscribe to the channel. And if you want to support us, you will find below the video link on Patreon and Gumroad, and we appreciate your support. Thank you, and see you in the next lesson. Have a good day.